Good afternoon, everyone. Welcome to CE 107. Your subject for today is hydrology. I am your instructor, Engineer Alay, and today I present to you the definition of hydrology. At the end of this topic, you, the students, should be able to understand and define hydrology, discuss the scope of hydrology, discuss the history of hydrology, enumerate and explain the different divisions and branches of hydrology and its related fields. One of the most important substances on our planet is water, which is vital to the survival of all plants and animals. Apart from drinking, humans have many other uses for water. And it is a major force that constantly shapes the Earth's surface. Water naturally recycles itself through the water cycle. In this subject, we will focus on the processes, origin, distribution, and properties of water. Kaunting etymology lang. Hydrology comes from the Greek words hydro, meaning water, and logos, meaning study. So basically, hydrology is the study of water. But by definition, hydrology is the science that deals with the waters above and below the land surfaces of the earth, their occurrence, circulation, and distribution in both time and space, their biological, chemical, and physical properties, and their reaction to their environment, including their relationship with living beings. And number 2, the processes governing the depletion and replenish of the water resources of the land areas of the earth, and the various phases of the hydrological cycle. Hydrology is a subject that is of great importance for the people and the environment. It treats the waters of the earth, their occurrence, circulation, distribution, chemical and mechanical properties, and reaction to the environment. Hydrology may be considered to encompass all the hydrosciences or be strictly defined as the study of the endless circulation of water between the earth and the atmosphere, referred to as the hydrologic cycle. Marapat lamang nabigyan natin ng importansya ang tubig dahil hindi lamang tayong mga tao ang binubuhay nito, maging ang mga hayop, kapaligiran, at ang ating daigdig. When we talk about scope, we are defining the extent of the area, or sa madaling sabi, yung nasasakupan ng subject na hydrology. Ano-ano nga ba ito? The study of hydrology helps us to know the maximum probable flood that may occur at a given site and its frequency. This is required for the safe design of drains and culverts, dams and reservoirs, channels, and other flood control structures. The water yield from a basin, its occurrence, quantity and frequency, etc. This is necessary for the design of dams, municipal water supply, water power, river navigation, and others. The groundwater development, for which a knowledge of the hydrogeology of the area, that is, of the formation of soil, recharge facilities like streams and reservoirs, rainfall pattern, climate, cropping pattern, etc. are required. the maximum intensity of storm and its frequency for the design of a drainage project in the area. Let us go down and dig some of the historical events that contributed to the development of hydrology. Way back 6,000 years ago, there were archaeological evidences of the irrigation projects of the Egyptians and Mesopotamians. Although the first time when water was first controlled is uncertain. In about 4000 BC, a dam was built across the Nile, and later a canal for fresh water was constructed between Cairo and Suez. The Greek philosophers were the first serious students of hydrology. The conversion of moist air into water deep inside the mountains as the source of springs and streams was proposed by Aristotle. An idea of an underground sea as the source of all surface waters was proposed by Homer. In around 97 AD, there were attempts of stream flow measurement in the water systems of Rome using the cross-sectional area of flow. Leonardo da Vinci discovered the proper relationship of area, velocity, and flow rate during the Italian Renaissance. In the 19th century, there are significant advances in groundwater hydrology that occurred. Some of these are Darcy's law, Jute-Fuitian formula, and the Hagen-Poiseuille capillary flow equation. Cho has named the period from 1900 to 1930 the period of empiricism for the large number of empirical formulas that were developed. However, many of these formulas were found to be unsatisfactory.
Let's bring it back to 90s, the modern times. The period from 1930 to 1950 was called by Cho as the period of rationalization. This produced a significant step in hydrology due to the development of new programs and hydrologic researches by the different government agencies. Some of these were Sherman's unit hydrograph in 1932, Horton's infiltration theory in 1933, and Thies's non-equilibrium equation in well hydraulics. Since then, numerous advancements were continually developed, such as the measurement, reporting, and forecasting of different hydrologic phenomena, the prediction of peak flow from floods in the 1950s and 1960s, and evaluation and delineation of floodplain boundaries in the early 1970s and 1980s. Since the 1950s, hydrology has been approached with a more theoretical basis than in the past, facilitated by advances in the physical understanding of hydrological processes and the advent of computers. So that is the end of my slide. I will see you again next meeting on Wednesday for discussion on the division, branches, and related fields of hydrology. Thank you and stay safe.